That gold bar you picture in your mind is older than Earth itself. It was born inside a dying star, blasted across space, buried in solid rock for billions of years, then dug up, melted, and poured into a strange wedge shape that hides a clever secret almost nobody notices. Welcome to Secrets of Everyday Things, the channel where everyday secrets are uncovered and explained. Close your eyes for a second and picture a gold bar. Go on, really picture it. Most likely what came to mind was not a perfect cube. It was that classic shape we have all seen in old heist movies and bank vault scenes. Wide at the bottom, slightly narrower on top, with sloping sides that look almost handcrafted. It feels iconic, it feels solid, and it feels somehow ancient. Well, here is something that might stop you in your tracks. The gold inside that bar is older than the dirt under your feet, older than the dinosaurs, older than the planet you are standing on right now. Every single ounce of gold humans have ever held was forged in violence we cannot even imagine, far out in deep space, long before Earth was anything more than a swirling cloud of dust. So how did it get from there to a polished wedge sitting in a bank vault in Manhattan? And why on earth is that wedge shaped the way it is, instead of a nice, neat cube that would be easier to make? Stick with me, because the answer is one of those quiet little stories where physics, chemistry, human hands, and pure, stubborn practicality all collide. This is the journey of gold, from a star that died billions of years ago to the strange shape sitting in your imagination right now. Let us start with the punchline. Scientists figured out only fairly recently. Gold cannot be made in a normal kitchen, a chemistry lab, or even a regular furnace. You can heat it, melt it, stretch it, pound it into sheets thin enough to read a newspaper through, but you cannot create it from scratch. The atoms themselves are simply too heavy. To build a gold atom, you need pressures and temperatures so extreme that nothing on Earth can pull it off. You need a star to die. When a giant star runs out of fuel and collapses on itself in what astronomers call a supernova, it releases a flash of energy so violent that lighter atoms get crushed together into much heavier ones. In those final seconds, gold, silver, platinum, and other heavy metals are forged in cosmic fire and flung outward across space at unimaginable speeds. Some of that stardust drifted for billions of years before it ever reached our part of the galaxy. When the early Earth was forming, it was a glowing ball of molten rock. Heavy elements like iron and gold sank toward the center, pulled down by gravity, and most of the original gold ended up locked deep inside the core where humans will never see it. So how did any gold end up close enough to the surface for us to dig out? The answer, believe it or not, is asteroids. About 4 billion years ago, the young Earth was pummeled by an absolute storm of metal-rich asteroids, an event geologists sometimes call the Late Heavy Bombardment. Those rocks carried fresh gold, platinum, and other precious metals, and they slammed into our crust hard enough to seed it with treasure. Almost all the gold humans have ever mined was delivered by space rocks raining down on a young planet. After those impacts, hot water trapped inside Earth began moving through tiny cracks in the rock. As that water cooled, it left behind veins of quartz, and inside those veins, microscopic flecks of gold quietly settled into place. Over millions of years, wind, rain, and rivers slowly chewed those rocks apart, washing tiny gold flakes into stream beds. That is why every gold rush story you have heard, from California in 1849 to the Klondike in the 1890s, started the same way. Some lucky person bent down by a creek, scooped up a pan of gravel, and saw a yellow flash that did not belong with all the gray. Now here's the part most folks do not realize. If you collected every single ounce of gold ever mined in human history, melted it all together, and poured it into one big block, the whole pile would only fill about 2 Olympic swimming pools. That is it. That is every wedding ring, every cathedral altar, every pirate doubloon, every Olympic medal, every gold tooth in every grandparent in every old photo, every bar stacked in Fort Knox. 2 swimming pools. All the gold humanity has ever pulled out of the ground would fit in your local YMCA pool with room to spare. That is why gold has been precious in nearly every civilization that ever lived. There simply is not very much of it. The Egyptians, the Romans, the Aztecs, the Chinese dynasties, all of them treated gold as something divine. partly because it shines, partly because it never rusts, and partly because no matter how hard they tried, they could not seem to make any more of it. That brings us to the modern question. If gold is buried in tiny veins, hidden inside ordinary-looking rock, how do mining companies even know where to dig? It turns out the search starts long before any shovel hits the ground. Geologists study old maps, looking for places where the crust folded, cracked, or boiled with hot water millions of years ago. They send up satellites to scan the land for tiny chemical and magnetic signatures that hint at metal deposits below. Then teams head out to collect rock samples by hand and ship them back to labs where every speck is tested. If even a few grams of gold show up per ton of rock, that can be enough to justify building a mine. Yes, you read that correctly. A typical gold mine pulls about 6 grams of gold out of every full ton of rock it processes. 6 grams is about the weight of a nickel. 1 ton of rock for 1 nickel-sized lump of metal. The math sounds insane, and it is, but at modern gold prices, it pays the bills. Once a deposit is confirmed, the real work starts. Some mines are open pits, dug straight down into the earth in giant stair-step terraces called benches. The pits get so wide and so deep you can see them from space. Others, where the gold runs deep, become underground mines with tunnels stretching for miles. Down there, temperatures climb past 120 degrees Fahrenheit. The air has to be pumped in, and water has to be pumped out. All so workers and machines can chase a thin, glittering vein through the dark. Workers are scanned and watched constantly because, well, you can imagine the temptation. When the rock finally reaches the surface, it gets crushed in stages. First, big jaw crushers break the boulders into chunks. Then ball mills, huge spinning drums full of steel balls, grind the chunks into a powder finer than flour. That powder is mixed with water and chemicals to form a thick gray slurry. From there, refiners use one of several methods to coax the gold out. Some plants float it to the surface with bubbles of air. Others rely on the fact that gold is incredibly heavy, so it sinks while the lighter waste washes away. The most common process today, called cyanidation, dissolves the gold into a liquid using a tiny amount of cyanide solution. The dissolved gold is then captured on activated charcoal, scrubbed back out, and finally melted in a furnace that runs hotter than 1,000 degrees Celsius. After one more round of electrical refining, what comes out the other end is shimmering gold so pure that 9,999 atoms out of every 10,000 are gold and nothing else. That is the famous 4 nines purity stamped on every certified bar. So now we have liquid gold, glowing red-orange in a crucible, ready to be poured into a mold. And right here is where the bar gets its weird shape. Because if you tried to pour molten gold into a perfect cube mold, you would run into a very expensive problem. As metal cools, it shrinks. If the walls of your mold are perfectly straight, the cooling bar locks itself inside the cube and refuses to come out. You end up tapping, prying, and sometimes destroying the mold to free a single bar. Now imagine doing that thousands of times a day. So refiners did what bakers and ice cube tray makers figured out long ago. They angled the walls slightly outward, wider at the bottom, narrower at the top. That tiny taper is the difference between a bar that pops free clean every time and a bar that turns into a daily headache. The shape of every gold bar in the world was decided by molten metal arguing with its own mold. But the wedge shape kept earning its keep long after the casting step. Gold is heavy. A standard good delivery bar weighs about 27 pounds, roughly the same as a small bowling ball, except packed into something the size of a paperback book. Now picture stacking thousands of those in a vault. Cubes would slip and shift on each other, and one wobble could send a small fortune crashing to the floor. The wedge sits flatter on its wide base, locks into place against its neighbors, and resists tipping. Vault keepers love it. They love it even more when humans have to actually pick the bars up. Try gripping a smooth, heavy cube while wearing thin cotton gloves. Now try the same thing with a bar that has slanted sides angled exactly where your fingertips naturally curl. The wedge almost grabs back. That detail alone has saved countless toes from 27-pound disasters in counting rooms around the world. Some of the best comments I have ever read on this topic put it perfectly. One person said gold bars are shaped like that so you cannot lift and steal them. Another joked the wedge keeps people from mistaking them for sticks of butter. both in their own way are right. There is one more reason for the shape, and it is small but clever. The flat top of the wedge gives refiners the perfect spot to stamp the bar's identity. The refinery name, the weight, the purity, and a unique serial number all get pressed into that smooth upper face, where they stay readable for 100 years even after countless hands and gloves have brushed past them. Eventually, the gold industry settled on the size, weight, and shape we now call the Good Delivery Bar. That standard is what allows a bar made in Switzerland to travel to Singapore to New York without anyone needing to remelt or retest it. The little wedge in your imagination is actually a global passport, accepted in vaults on every continent. So the next time a movie shows a stack of gold bars, take a closer look. That gentle taper is not just style. It is the ghost of a dying star, the memory of an asteroid storm 4 billion years old, and the quiet handshake between molten metal and its mold. It is centuries of miners, refiners, and vault workers all whispering, "This is the shape that just works." From the violence of supernovas to the calm of a vault floor in Switzerland, every step of that long story is hiding inside a bar small enough to hold in 2 hands. If you found this little journey as fun as I did, do me a favor and hit that like button, leave a comment, and subscribe so you do not miss the next strange story behind something you thought you already understood. And before you go, here is something I would love to hear from you. If you could hold one gold bar in your hands right now, what is the very first thing you would do with it? Drop your answer in the comments. I read every single one, and I have a feeling some of your stories are going to be a lot more interesting than mine.